this video, the transformation that we're going to be talking about is translations. In geometry, you were used to translating in any direction, but in algebra, since we are specifically looking at the coordinate plane, we are only going to be translating horizontally, which is to say right or left, and vertically, which is to say up or down. So these have a lot of similarities, but they have some important differences too. So first, let's look at a vertical translation. So we would have an original function, f of x. And I'm just using a general function here, but this would work for any kind of functions. So our translated function, we'll have it move up. And so this is our new function, g of x. And we're going to say that it is translated up by k units. So we're just going to use a variable here. To find our equation for g of x, we would have to think about what's happening to each individual point when we go from f of x to g of x. So for a point right here, when we move from f of x to g of x, the x value stays exactly the same, but the y value increases by k. So our general formula is going to be f of x plus k. So if k is positive, then we'll be adding something to each y value, and so the translation will be upwards. If k is negative, we'll be subtracting from the y value, and the translation will move downwards. In a horizontal translation, again, we'll start with an original function, f of x, but in a horizontal translation, our g of x will be moved to the right or left instead. So what's happening to an individual point in f of x is that it would be moving to the left some number of spaces. Since we're affecting the x values instead of the y values, that means the input of our function is going to change rather than the output. So when we find our value for g of x, instead of adding something to the output the way we did here, we're going to be modifying the input. And our equation will be f of x minus h. And we'll talk about that a little bit more. But an important thing for you to notice is that in the vertical translation, we had plus k, and so if k was positive, we were moving upwards. In the horizontal translation, we have minus h. So a translation in the positive direction will end up looking like subtraction in our transformed equation. So to see why, let's do a really quick example of f of x equals the absolute value of x. So in the original function, we have the reference point 0, 0. And then in a transformed function, we're not going to have the point 0, 0 anymore because our function will have moved to the right or to the left. So let's say we are looking for the transformed function g of x equals the absolute value of x minus 2. If we want to know what's happening to our reference point, we would want to find out what value of x would give me g of x is equal to 0. So if I look back at my equation for g of x, I know that the absolute value of 2 minus 2 would give me 0. So g of 2 is equal to 0, which means the point 2 comma 0 is my new reference point. So even though we were subtracting 2 from the x values, we ended up moving in the positive direction, which is to the right. So you'll see in horizontal transformations that when h is positive, that means you'll be subtracting and it's a move to the right. When h is negative, you'll be adding, because if you subtract a negative, that makes positive, and you'll be moving to the left.